We've talked about balanced forces where an object is going to remain motionless because all the forces on it are balanced out. Now let's talk about unbalanced forces where we're going to have some resulting force. There's a couple concepts we need to keep in mind here. First off, we're going to have an applied force, okay? We're going to call this F1 or F2 or F3. If it's a numbered force, it's an applied force. Secondly, we're going to have a force due to gravity. And for now, the way we're going to define that is it's going to be about the mass times 10. Then we're going to have a force normal, which will be equal to the opposite of the force of gravity. And just to keep our frame of reference nice and tight, let's say force of gravity will be negative. So let's make this a negative 10. And then we're going to have a force of friction. And that's going to be equal to the force normal times the coefficient of friction. And we're going to be using coefficient of kinetic friction pretty much all the time. Now, lastly, what we're looking for is a net force. F net is going to be the addition of all of the forces in a particular plane. And so in these contexts, our F net is going to be F net in X, okay? So think of this as being horizontal. And that F net is going to be the sum of all of the forces in X, okay? That's what epsilon means, it's the sum of. But in this context, specifically, it's going to be F1 plus the force of friction. Now, we can do everything we can to keep our negatives and positives nice and straight. But when we draw out forces, we'll need to use free body diagrams. A free body diagram, remember, is just drawing a box, drawing the forces on it. So if I've got an F1 here, and a force of friction here, these are pointing in opposite directions. One of these must be negative. Convention says force of friction should be negative, but it really makes no difference. We just need to make sure we're keeping our frame of reference in mind here. So let's go ahead and set up a problem. Let's say I've got a box, just a nice clean box. It's got a mass of, let's just start with 10 kilograms. And it's got an applied force of, let's say, 120 newtons. The surface that it's on will provide a coefficient of friction of 0.7. I want to know, what is my F net? So first thing I need to do is I need to define all of the forces acting on this. So I'm going to make a variable list. I've got F1, I'm going to have a force of gravity, I'm going to have a resulting force normal, a force of friction, and finally an F net. My force, my applied force is 120, I already know that, that's given. Force of gravity, that's going to be my mass times negative 10. So this is going to be negative 100. So I'm going to have force of gravity here. And then force normal is going to be the negative gravity, so it'll be 100. It'll be here. So those will balance out. And then my force of friction will be that Fn times the mu k. So that's going to be 100 times 0.7, which will be 70. Finally, the force net, F net, will be 120 plus, and remember, force of friction is going to be resisting that, so it's going to be in the backwards direction. So that's going to be 120 plus negative 70. So it'll be 120 minus 70. 12, 120. And that will give us 50. So my F net is 50 newtons. There we go. Nice and straightforward. Let's do another one that's a little more complex, because that was actually pretty straightforward. So let's try something that's pulled at an angle. So I'm going to apply a force right here, and I'm going to apply it at a degree of, let's say, 25 degrees. And so I'm going to use a force, an applied force of, let's go with 250. And let's give this a mass of 17. And then a mu k of 0.5. Now I want to know what's going to be my F net. Now, I'm going to solve this in much the same way, except that this applied force needs to split up into an x and a y. So let's make a variable list, keeping in mind the F in x and the F in y. And we're going to need to add those to our free body diagram. All right, so F1 is going to be 250 newtons. Now Fx is going to be F1 times the cosine of theta. And Fy will be F1 times the sine of theta. Let's go ahead and figure those out. So my Fx is going to be 226.6 newtons, and Fy is going to be 105.7. Now my force of gravity will be 17 times negative 10. That'll be negative 170. And my force normal, this is now going to be a little bit different. Because first off, look at where my forces are. I've got my force of gravity right here. Let's actually do this in a few different colors so that we can keep everything straight. Got my force of gravity here. I know I'm going to have a force normal here, but I already have a force going up in my vertical plane. What force is that going to be? Well, that force is going to be the component force here, Fy. Is this object going to lift off the ground? If my Fn is 170, it would. But is Fn going to be 170? Not so sure. Let's put our Fx here before we move on. So to find Fn, what I really need to remember is that this force normal is going to be the force that the ground pushes back up on the object with in order to support it. So if I'm holding something near the ground, but I'm lifting up on it a little bit, well, the ground's not going to feel it as much. So what's really happening is this force in y is relieving some of that weight, some of that gravitational force off of the ground. And so the ground doesn't have to push up as hard. So we can modify this equation right here. So let's adjust it just a little bit. I'm going to say that Fn is equal to the force of gravity minus the force in y. And now we've described force of gravity as being negative. So how can we write this to make sure that our Fn will be the opposite sign of our force of gravity? If I want my signs to be correct, I need to make Fg a negative. Okay, so let's try applying that. In this problem, I've got my Fg is negative 170, so I'm going to say negative of negative 170 is 170, minus Fy, which is 105.7. That gives me an Fn of 64.3. So Fn is going to be 64.3, and now I want to find my force of friction. Now my force of friction is going to be going back this way. And I just don't have a lot of space here. So my force of friction, how am I going to find that? That's going to be force of friction equals my Fn, which is 64.3, times my mu k, which is 0.5. And that's going to give me 32.15 newtons for force of friction. And now finally, my F net. I can now solve for my F net, which is going to be my applied force in x of 226. Because remember, this F net is only going to be in the horizontal plane. So 226 minus my force of friction, which is really plus a negative force of friction, which is 64.3, which will be 162.3 newtons. So my F net is 162.3. There we go. So when we're solving these problems, when we have component forces, what we really need to keep in mind is that we need to break these components, or these vectors, up into their individual components, into x and into y. And when I do that, I need to keep in mind that those forces will interact with these other forces. If I have an Fy, it will impact how my gravity and force normal are related to each other. And if I have an Fx, I will need to use that instead of my F1 in order to find my F net.